Hello everyone. Today we are going to discuss some compounds of group 16 element. First compound is the oxygen, that means dioxygen molecule. Now what are its preparation methods? See, first one. I'm writing preparation, okay? Preparation. First preparation method is the when we heat potassium chloride first. Heating of potassium chloride, okay? Potassium chloride. Potassium chloride is, suppose, KClO3 is the potassium chloride. When it is heated in presence of a catalyst, okay, in presence of a catalyst is the manganese dioxide, and heat we obtain 2 moles of potassium chloride plus 3 moles of oxygen. Second preparative method is the thermal decompositions of chemicals. Suppose when 2 moles of Ag2O solid, silver oxide solid is thermally decomposed, that means in presence of heat it decomposes to give 4 moles of silver solid plus O2 gas. Similarly, some other methods also, if we write, suppose lead oxide when heated it produced lead oxide, this is solid, plus O2 gas, okay. Third preparative method, the decompositions of hydrogen peroxide. When hydrogen peroxide decomposes in presence of a catalyst name is manganese dioxide, that means MnO2, we obtain 2 moles of H2O liquid plus O2 gas, okay. These are the preparative methods of oxygen. Now industrially, oxygen is prepared some different type of reactions. Experimentally, oxygens are prepared in some different types of method. Mainly, one of the well-known method is the by removing carbon dioxide and water vapor from the air. By removing carbon dioxide and water vapor from the air. See, next is the properties of O2. Properties. Now what are the properties? See, oxygen is colorless, odorless gas, okay. Colorless, odorless gas. It has 3 isotopes. First isotope is 16 oxygen, 17 oxygen, and what? And 18 oxygen isotope. Now what do you mean by isotope? Isotope means their atomic number is same but the mass number is different. Next thing, O2 is paramagnetic in nature. Paramagnetic in nature. This one is your homework. Paramagnetic. Your question is, why O2 is paramagnetic in nature? The answer of these questions you may get from the class 11 concept, that means MOT. If you see the MOT, you will observe that in the upper level of orbitals, some unpaired electron is there. Due to that unpaired electrons, the O2, that means O2 molecule, behave as a paramagnetic. Okay. Now see some common chemical reactions of oxygen. Suppose some common chemical reaction. Okay. When calcium, when calcium react with water, it produces calcium oxide. When phosphorus reacts with water, it produced oxide of phosphorus. That means P4O10. This one is a common reaction. Okay, P4O10. Suppose we are using ZNS react with 3 moles of water. Here should be true. We get 2 moles of ZNO plus 2 moles of Acetic. Really? And some chemically catalyzed or chemically oxidized reactions are in this way. Okay. One more common reaction is when methane reacts with water, it produced carbon dioxide plus water. Okay. Now, catalytically oxidized reaction. Catalytically oxidized reactions are, suppose when sulfur dioxide reacts with O2 in presence of vanadium pentoxide as a catalyst, it produced 2 moles of sulfur trioxide. Okay. Another example, when 4 moles of hydrogen chloride, that means hydrochloric acid, reacts with O2 in presence of copper chloride as catalyst, it produces 2 moles of chlorine gas and water. Okay. Next thing is the uses of O2. Uses. This thing you just see from your book. Okay, in page number 185 it is given clearly what are the uses of O2. Okay. Next, see. Next, two very important question answer in your intakes. The question is, which of the following does not react with oxygen directly? This reaction of metal with oxygen is depend on their reactivity. That means the metal which is least reactive does not react with oxygen, and the metal which is most reactive reacts with metal. Here in this zinc, titanium, platinum and iron, platinum is the least reactive. That means you can say noble metal. Noble metal means it does not want to react with other elements. Okay. Next is the complete the reaction. When ethane is react with water, it produces carbon dioxide and water. Similarly, when aluminum reacts with oxygen, it produces aluminum oxide. That means Al2O3. Okay. See the next. Next is the oxides. Oxides of some element. See. Simple oxide. Simple oxides. See, what do you mean by oxide? Okay, oxide means a binary compound of oxygen with another element. Okay, oxide means a binary compound of oxygen with other element. Now oxides are of 3 types. Oxides are of 3 types. First oxide is acidic oxide. basic oxide and neutral oxides. Now, what do you mean by acidic, basic, and neutral oxides? The oxide which reacts with water and forms the acid these are acidic oxides. Similarly, the oxide which reacts with water to form base is called the basic oxides, and the oxide which reacts with water does not produce either acid or base. It called neutral oxide. This neutral oxide is the known as amphoteric oxide as well as. Okay. Now we will see one by one why it is called. Now see, first one is acidic oxide. Okay. See, first one, acidic oxide. An oxide that combines with water to give an acid. Okay, is termed as acidic oxide. Okay, acidic oxide. For example, we are writing, suppose, SO2, Cl2O7, carbon dioxide, and 2O5. Now we are writing a chemical reactions using, suppose, SO2. See, when SO2 reacts with water, it produced H2SO, okay, H2SO3, and its name is sulfurous acid. Sulfuric acid. Okay, easy, no? When a oxides is react with water, it produces acid, and it's known as the acidic oxide. Okay, now see the second one, that means basic oxide. Similarly, oxide which gives a base with the reaction of water, it called the basic oxide. The oxide which give a base with water is known as basic oxide. Okay, and some examples of basic oxides are, suppose, Na2O, calcium oxide, barium oxide. Suppose we are writing an example with calcium oxide. Suppose calcium oxide, when react with water, it produces calcium hydroxide, which is a base. Calcium hydroxide, it is a base. Okay, see. Now from these two topics, that means acidic oxide and basic oxide, what we can conclude? We can conclude that the oxide which is made with the non-metal forms acid. The oxide which is made with metal is formed base. Oxide of non-metal are acidic, and the oxide of metal are basic. This is the conclusions from these two topics. Okay, next is the neutral oxides. Next, see how. One of the well-known neutral oxide is the aluminum oxide. Okay, now see how. The oxide which has dual behavior Dual behavior means acidic plus basic, okay, called neutral oxide. Neutral oxide. But remember one thing, this behavior comes from the reaction of acid and the bases. Okay. Now what is the conclusion? Conclusion is that they can react with acids as well as base. Okay. Since they can react with acid as well as base, that's why they known as amphoteric oxides. Now see how. Let us take an example of aluminum oxide. Suppose so aluminum oxide when react with HCl, 6 mole of HCl, it produced here 9 mole of water is there. Okay, 9 mole of water is there. When it reacts, it produced 2 moles of aluminum water 6. One is coordination complex aqueous plus 6Cl. Okay, it is react with acid. Now what happens if it reacts with base? Suppose and another aluminum trioxide is there and it's reacting with base, okay, plus 3 moles of water, it produce twice Na3 AlOH6. See, both are salt. Okay, this one coordination complex, this one also coordination compound, but it is salt in nature. That's why you can say the oxide which can react with acid as well as base are known as what? Neutral oxides or amphoteric oxides. Now, why does it called a neutral oxide? Because after the reactions, the product which is formed is not in acidic or not in basic. That's why it is known as basic. Sorry, neutral oxide. Okay.